So, good evening, everybody. Evening in Australian time. Welcome once more to Next Generation Network Security, Module 4, Security Operations. I hope you're having a good time wherever you are in the world today, this morning, tonight. As always, we will just give everybody 2 or 3 minutes to come into the Zoom chat and then we'll start properly. But please feel free to remember to say good day in the chat. Remember to post your things to everyone, not to hosts and panelists. Otherwise, we will see it, but nobody else will. And let's face it, you want to talk to other people, not necessarily just to us. So I'll be back on in a second and we'll get going. I'd like to welcome everyone to Next Generation Network Security. It's Module 4 tonight, our last week. It's on security operations. It's a big warm welcome to everybody that stayed with us for the whole 4 weeks. I know it can be a bit of a slog getting up and doing a free course when you're either early in the morning, late in the evening, or even mid-afternoon. So we really do appreciate it. These short courses are put on by IT Masters in conjunction with Charles Sturt University, our university partner here in Australia, who have been with us now for over 22 years. We've been working with them on these sorts of courses and our graduate and postgraduate programs. Before we get started tonight, I would like to remind everybody about the survey. We really like it when we get results back from the survey because it does guide us as to what courses we might do in the future and what you thought of what we offered up this time around. So please let us know what you think and how it's gone for you. So I think with no further ado, we will remember also to, set your chat to everyone. I can see lots of people are here from all over the world. But I would like to say a big thanks to Lil, who will look after the chat tonight. Any questions about, mechanical stuff, logistics, etc. Lil is your person because she looks after our short courses mailbox. So she will get the questions at some point, even if not immediately on the chat. And it's really over to Ian this evening. How are you tonight, Ian?
I'm well, yourself?
Very good, thank you.
And welcome everybody. Hope you're having a good day as well, as Shane said. And for those in Melbourne, I hope you have a lovely day off tomorrow as well. So, yeah, let's, I guess, get into it. As Shane said, we're going to cover security operations tonight. So this is more around the mechanics of security, how you address and deal with security, both incidents and management wise. And beyond the chat window, obviously, if you've got questions that you'd like to have answered, please feel free to put them in the Q&A panel as well. So with
That's a
that,
good
let's.
reminder, actually, because I forgot to mention it. But also, I will say I can see people are trying to raise their hand. We don't use the raise your hand function. So put your questions about, logistics into the chat and the other questions in the Q&A, and we will get round to answering nearly all of them, we hope, at some point. There have been lots of really good questions through these last sessions.
Absolutely. All right, so without further ado, let's get on to it. So our topics tonight are really around these 6 items. We'll start with what the SOC is. For those that aren't familiar with what the SOC is, we'll explain what it is. It's not something you'll find in your laundry basket. We'll talk about security operations or SecOps and a very closely related topic, DevSecOps, which is development security operations. We'll talk about seams and saws. We'll talk about how you might approach an incident, how you might approach incident management and analysis, and we'll talk about security operations engineering. So with that, let's move on to the SOC. So the SOC is otherwise known as the Security Operations Center. So what is that, you might ask? Essentially, it is first and foremost a team of people that will typically identify, investigate, mitigate, and manage threats and incidents. You might also know them as a security intelligence center in some organizations, or as an incident response team, which is actually a much older term for the same general function. And generally, from a managerial and organizational perspective, the SOC really has a role definition that comes through mission, governance, and planning. where the mission, as with any good mission statement, will define what the SOC is to do, how they're to do it. That is, what are their objectives? And obviously, an objective may well be to, minimize or eliminate the number of active securities that might be occurring in an organization. That might well be a stretch goal because, in practical terms, there's always going to be something happening that the SOC need to be involved in, particularly in a large organization. Governance, obviously, that's the measurement part of this process. That is to say, how do we determine what it is the SOC is going to achieve, and how do we measure success? What are we doing to ensure that the SOC is actually achieving its goals? Obviously, the SOC is generally a cost center within an organization. That is to say, it doesn't generate revenue for a company or an organization. And in turn, that means it's important to understand upfront what it is to be a successful SOC, particularly in an organization that may well see security as, the historical department of no. Unfortunately, security teams do have a reputation for being the place where, good business ideas go to retire. And obviously, part of that mission has to be business enablement, and part of that governance is how do you measure that when the SOC, by its definition and in terms of risk management, is inevitably going to have to put the brakes on some ideas for fairly good security reasons.
I
And
had a,
then, of course, sorry, go
I
ahead.
was going to say I had a guy who was a senior engineer, and you would open his door, and his first word would be no.
Yes, yes, I've worked with people like that, and interestingly enough, security teams do tend to collect a few of them. It's certainly not unique to security. Sysadmin teams are also renowned for it, and I can say that as a former sysadmin. Um, but and while many a word spoken in jest comes to mind, while people like that might be saying it tongue in cheek to a degree, the reality is obviously that quite often that is in fact their default mindset, or it can be the default mindset. And that's obviously something that needs to be managed very effectively at a business level. While a SOC and a security team is inevitably going to have to consider risk as a part of their job and manage that risk, it's also important to realize that the business needs to be able to function. And that, of course, all falls into then some planning. How is the SOC actually going to do what it needs to do? Now, maybe minimize or eliminate as best as possible the number of active incidents that an organization is dealing with. Perfectly noble goal, but how do you get there? What tools do you need? What resources do you need? What policies and procedures do you need to have in place, and who needs to agree with those in order to allow the SOC to be both effective and not seen as obstructive? So the SOC typically is made up of, as I've said before, many, it's a team. It's usually, several people, depending on the size of the organization. And there are fairly well-defined roles within that. One of the roles that the SOC has, and therefore typically that people within the SOC will have, is that of case management. Now, in this sense, what I'm talking about is any incident, and I'm actually using a term that comes straight out of the likes of ITIL, the IT Infrastructure Library. Anytime a problem or a threat or a security violation or whatever else it is that you might be managing appears, that's going to be treated as an incident. That's probably going to have a support ticket associated with it. And that in turn needs to be managed through to completion, whatever completion ends up looking like for that incident. Obviously, those incidents need to be documented. You want that case history so that, one, if things blow out of proportion later, you've got the ability to go and pull that data out and analyze it. And there's been plenty of times in my history where you deal with an incident, you close it out, you think it's all done, and then 6 months later you discover that actually that was the tip of the iceberg for a much, much bigger security incident that simply went unreported or undetected at the time. And obviously there's some lessons learned there as well. That forms part of that documentation and that debrief. And similarly, many times those incidents are going to have to be escalated to third parties. So, for example, I work very closely with a large network security vendor. We have customers who will regularly flag particular classes of incidents to us. Um, Not necessarily faulty equipment, of course. We could be dealing with, detected security problems that need further investigation on our side, and that's the sort of escalation that we would typically see a SOC have to do. It might be to go to a government computer emergency response team, such as OzCert, or the reverse is also true, where a report of an incident comes from either a CERT or from another government agency, depending on the nature of the issue. Now, where are those cases going to come from? They might come from system logs from various devices around the network, might be from firewalls, might be from servers, you name it. It might well be from staff reporting. Oh, look, I clicked on a link that I shouldn't have, and now I'm scared that my password's been fetched by a third party, a form of phishing or spear phishing, if you will. It might be that you become aware of a public vulnerability or a publicly disclosed vulnerability that affects the equipment that you own or may affect it. And it indeed may be all of the above and many other sources as well. All of these things can become incidents that need to be dealt with and addressed. And as a result, case management is one of the big roles of the SOC and therefore of the people within it. This all then falls straight into metrics as well. Obviously, you can't manage what you can't measure. And the converse is also true. If you're measuring the wrong thing, you'll end up managing the wrong thing. So if, for example, your metric to close incidents as quickly as possible, that can actually lead to very, very poor behavior where cases are closed before they're fully addressed. People look for reasons to close things out quickly. Similarly, if, say, the SOC's approach as measured is to, minimize the level of risk that the organization is exposed to, that may well actually lead to very poor behavior where, per the earlier comment, the SOC just become the department of no. It's easier for them to say no, and they can hide behind the metric of, well, we're trying to minimize risk here. That then gets straight into governance. The business has to be able to function. If a SOC is part of a business or an organization, that organization exists to do something other than manage security incidents. The SOC's role is managing security incidents, but in turn, the SOC needs to be able to do that in the context of accepting that the business is going to take some risks. That level of risk depends on the organization. It depends on what obviously a major bank, for example, is going to have a very different risk profile to a 20-seat IT firm or a not-for-profit or similar. And in some cases, that level of risk and function is very clearly defined by things like government legislation. Either way, the business and the SOC need to agree on how much risk is acceptable, and how do you measure that? Do you use a measure like annualized loss expectance? Do you say, well, on average, we expect to lose X dollars to security incidents per year? And do you then use that to calculate, what risks are worth taking? Or, do you have a legislative requirement to do things in a particular way? In any case, this, all of these things are part of what the SOC needs to consider. And typically, the SOC will roll up to a chief information security officer or similar, whose role it is essentially to advocate at the business level, both for the SOC and for the business itself. Okay, we've got a couple of questions coming in. So before I move on to security operations, the pillars, I might just see if what's
I
worth
think
doing.
it's pretty interesting about how are SOC costs justified in corporate books. That's pretty.
Yeah, that was actually the question that leapt to mind first. So Raghu has asked, how does the SOC justify its costs in corporate terms? Really, it comes down to seeing the SOC as a form of insurance. Without a security operations team, um, any breaches or any security incidents that might occur are going to typically be handled in a different and potentially ad hoc manner, and that in turn has a certain impact on how quickly it's going to get responded to. In turn, that's going to have an impact on the cost of that breach or that security incident. It's unrealistic in many organizations to expect a completely trouble-free run from a security perspective. So in most organizations, there will be something, even informally, that resembles a security operations center, even if it is something that the IT admin does as a part of their overall job. And really, it comes down to that insurance policy. It comes recognizing that spending a certain amount of money on having a security posture is cheaper than the alternative, which is to not do so and potentially have to pay lots of money in fines, potentially, particularly under various forms of legislation, have the reputational damage that goes with it, and so on and so forth.
Not to mention other costs. I'm sure it's part of your insurance profile, and your insurance company is going to be looking at that sort of stuff these days.
Absolutely. So I'm actually on a board of a not-for-profit that's currently going through getting cybersecurity insurance based on very good advice that they received from an insurance auditor. And one of the questions that has come up is, essentially revolves around how much risk management is the organisation doing to essentially mitigate the insurer's risk and therefore reduce the premiums that we'll have to pay. And while a lot of that revolves around things like, how good is our password policy and so on, it also does revolve around how do we deal with incidents? What is our response policy, which if we weren't a small not-for-profit would almost certainly be a part of, part of a full security operations team.
Is the SOC an area where AI is likely to have a lot of impact, particularly in reducing workloads?
Yes, and actually we get to talk about that as part of talking about seams and saws. So let's
Hey,
get onto that in a little while.
Uh, yeah, do you want to talk about security operations? What criteria you use for high, medium, or low severity? How do you tell them apart?
Yeah, let's do that. So Canal has asked, what criteria are used to classify incidents as high, medium, or low. There are a range of different classification mechanisms. There's the National Institutes of Standards and Technology out of the United States has done a very good and very well used risk matrix approach, where essentially, and the NIST approach is certainly not the only version of this, but essentially takes likelihood of occurrence and impact and breaks that up into basically a 5-row matrix, from negligible to extreme, and takes that against the impact should that risk become realized. Um, so that basically, you know, what's the actual impact of it? Should the incident become a real deal, versus how likely is it to actually occur? Now, that helps you manage the risk side of the puzzle. Obviously, an incident is something that's already occurred. Typically, that first, that a lot for a lot of your more common risks, you're going to have a fair sense of the um, of the impacts based on having that sort of risk register done up, where you've sort of pre-populated and said, well, if we lose a password due to a phishing attempt, this is the likely impact. And so having those sorts of playbooks pre-programmed will also allow you to sort of automate in process the the response to those incidents. Um, in terms of how you would typically classify incidents, you'd typically define beyond what I've just described in a process, um, potentially dollar values, um, where you would say, well, a high priority or high severity incident might have a value of, for argument's sake, $100,000 or greater. A medium might be between $99,999 and say $25,000 for argument's sake. And those dollar values are essentially just an expectation of loss based on that incident. Obviously, when an incident occurs, you don't necessarily know up front how much money you're going to lose as a result of it, but you can generally have a pretty good gauge of what the remediation costs are going to be, what the potential reputational damage is going to be, and so on. Some of that will also involve things like the data that has been lost. Obviously, if there's been data loss and it's personally identifying information of your customers, there's going to be government impacts there. It tends to get fairly expensive fairly quickly.
Right. Let's chuff on.
Yep.
I thought
Awesome.
also that we might put that NIST grid you were talking about in the forums, maybe.
Yes, yeah, I'll do that. Yeah, remind me after, or remind me
Yes.
afterwards, and I'll make sure I do. Um, so let's talk about the 6 pillars of an effective security operations group or team, or more generally of the process of security operations. So first pillar, most important, is the business itself. There is absolutely no point having a security operations team if the business isn't functioning. And if the security operations team prevents the business from functioning, that is fundamentally the same outcome. People are critical here as well. Security operations team with no people in it, AI or no AI, is not a security operations team. Unfortunately or fortunately, AI is not, and probably won't be for a very long time at least, in a position to completely automate away the security operations team. Interfaces. This, I don't mean network interfaces or connections or plugs. I'm talking about with whom the security operations team need to interact on a daily basis. So this might be the local CERT in your region. So CERTs are typically these days government or government aligned organizations, computer emergency response teams, that is, whose job it is to essentially help coordinate major security incidents. So they tend to have very good visibility of what's going on in the world. Obviously, they can see a lot more than just any one organization. And so they can also tend on how to deal with an incident should it occur. They also tend to propagate down information based on what they're seeing. So if, for example, there's a major security vulnerability that has just been detected, and you're a member of a given CERT, they will typically make sure you're informed, including on how to best address it. And obviously that then, the SOC then have to promulgate that advice within the organization itself, based on the specifics of that organization. So a CERT will tell you everything, and then it's up to a SOC to determine what is actually relevant within the organization itself. Visibility. Obviously, a SOC that can't see what's going on isn't a SOC at all. So they need to be able to see things like log information from firewalls, from network devices, from servers. We'll talk about a couple of the tools that might be used to achieve visibility in that sense. But that also extends to understanding the business itself. It's all very well to have visibility of all of the technical information, but without understanding how the business actually works and operates, a SOC is not really able to achieve its goals. So they need to be able to see what the business is trying to achieve and how, but they also need to be able to see what's going on from a traffic point of view, what's going on from a threat point of view. They need to see if there are threats that are active within or around their environment. And they need to be able to see how the various devices, security and otherwise, are responding to that within the environment. Technology is key here, of course, and yes, AI is a part of that, but so are various log aggregation systems, event correlation systems, and so on. And just as important in all of this is a good set of processes. A SOC needs to be able to perform its functions in a repeatable fashion. And the best way to achieve repeatability in any business is to have defined processes that define what those what those outcomes should look like and how to get there. They don't need to be fixed, and in fact, it's best if they're not. There should be some flexibility in their implementation, but nonetheless, they need to be there and potentially tailored and adjusted over time as you learn more about what did and did not work. Okay, let's get into just having a quick look. I'll move on to SecOps, I think. So we'll now talk about security operations and development security operations. So these two terms are relatively new. They come out of the same world as DevOps, which I'm sure many people have heard of here. And essentially, SecOps takes the same sort of continuous integration approach that, continuous improvement approach that development operations first concocted over the last 20 odd years and applied them to the concept of security. So for those that are not completely across DevOps, essentially DevOps takes the old separated model where programmers would program, and then once they'd finished building software, they'd essentially toss it over the fence to a completely separate operational team who'd then be charged with trying to make whatever it was they'd just been thrown work. That process was always the way of the world until relatively recently. It sort of started, the concept of DevOps really started to take flight around 20 years ago and has really taken flight in the last sort of probably 10 years, I would say. And really the concept of DevOps is that you remove that boundary between the operations team that are responsible for keeping the lights on and the development team who are responsible for producing code, creating new functionality, and so on. SecOps essentially tries to get rid of the same sort of boundary. Operations teams traditionally tended to operate somewhat in isolation from what used to be called the incident response team, where essentially the system administrators, the system operators, would typically have a very good sense of what security meant to them, but wouldn't necessarily be looking at that from a whole of environment view, because they had their own environments to worry about. So really the concept of SecOps is to embed security right down into that operational view, but make sure that it's seen holistically as well. You want, obviously, any security instance to be dealt with across the organization, particularly in today's world where many security breaches use multiple methods of entry, multiple attacks, multiple breaches, the aim of getting significant amounts of data out of an organization. And that all forms part of what we called in an earlier week, advanced persistent threats. So essentially, though, SecOps, it revolves around four main functions, which essentially run in a loop of sorts, where an alert comes up. It might come from something automatic. It might come from somebody noticing something odd. It might come from somebody clicking on a link and handing their password over to somewhere that they probably shouldn't have. That then leads straight into an investigation. That investigation can be pretty quick in some cases, but doesn't just stop at figuring out what happened with the incident itself. Part of it is trying to understand, how did we get there in the first place? Is there a procedural or a process problem that needs to be dealt with? Is there something else that we could have done to avoid this happening in the first place? And of course, just as importantly, how big of a deal is this? Is it something that's been contained to a single device that we can remediate pretty quickly, or has this got the potential of having gone throughout our network, had us lose data to a third party or what have you. Mitigation falls straight into here as well. That is, we need to stop the attack. We need to undo the damage as best we can. Now, in some cases, that's going to involve, you know, basically going back to clean slate on a particular device or systems. In some cases, it might be as simple as locking somebody out using adding a new firewall rule, for argument's sake. And then, of course, all of that information, and I've alluded to it with the investigation component, leads to improvements. Obviously, a good SOC will be continually learning, continually understanding what's going on, and won't just look to change what the organization does, but will also look to see what can be done to improve how the SOC operates as well. That then gets straight into DevSecOps. So DevOps, obviously, like many components of software development, hasn't generally treated security as priority number one. There are, of course, exceptions, and I apologize in advance to any developers who are instantly offended by what I've just said. But as somebody with a software engineering background, I think I'm relatively qualified to say that security does tend to get treated as something that gets added on. And of course, you can't, you cannot do that with software. Security has got to be a part of the whole process. Security has often been a separate team, and see previous comments about the Department of No. Quite often, developers will actually see security as a roadblock and do everything in their power to work around them. In years gone by, I've worked with development teams that, for example, wanted root level access to various Unix type systems, so Solaris, for example. And upon getting that, because management insisted, promptly managed to erase entire servers purely by accident. So obviously, that particular discussion came out of a belief on their side that security were against them. And security, unfortunately, in that case, had their worst fears confirmed by the fact that they suddenly had a bunch of servers that were no longer available. And of course, availability is absolutely a part of security. That could have all been addressed at the time, of course, by finding an alternative way to achieve what it was the developers were looking to achieve, which was to run certain applications in a more privileged manner. But in any case, DevSecOps is all about getting all of these teams to work very closely together and very iteratively together. That is to say, making sure that as and when things happen, those learnings are immediately rolled back into the process as it goes. So essentially taking a very test-driven development approach to security, where security forms a part of essentially the checklist that's required to take code into production from the development chain.
I would like to say, just while we're here, is anybody who's interested in DevOps, we did a short course on DevOps at the end of 2022, which is still available on our system.
And it's certainly a topic that's worth exploring more, whether you're in software development or in system management or system administration or in security. It's worth understanding how DevOps functions, because more and more that philosophy, that method, is being applied to, well, things like security, things like operations more generally. Even in teams that don't do a lot in software development are starting to use those same methods. Okay, let me have a quick look.
What's the best practice for an organization to provide DevOps access for a live environment?
So that's probably the best way to answer that is to attend a course on DevOps itself, dare I say, because that in itself is a fairly involved discussion. But generally speaking, the whole concept of test-driven development is that philosophically you start with writing test cases that are designed to prove that a particular piece of code or a particular piece of functionality has met its requirements. You then work backwards and write code that passes those tests. And then you can have automated tools that will take that passing code and deploy it into, a production environment relatively quickly. And obviously, I am absolutely, grossly oversimplifying that process, but that in broad terms is what it's about. And SecOps and DevSecOps basically just extend on that and include sort of security tests and security benchmarks, fuzzing and so on in that process.
Are there predefined frameworks for implementing security in the dev stage?
There are, again, that's probably a bit too broad a question to give fairness to in a 90-minute long presentation. But essentially, DevSecOps itself is a set of frameworks. And again, like this topic alone could easily be a 4-week short course.
Great. How do we encourage and entice buy-in from management and the dev team to adopt DevSecOps?
That is an excellent question. I love it because it's the biggest problem. Developers continue to see security as a roadblock. That is natural. It's unfortunate, but it is a natural behavior. And so I guess the first step is for the dev team to understand that not only is security essential, but they are actually there to help the organization. Second to that, from the management point of view, it comes back to the same comments I made about insurance earlier. Basically, the organization and therefore management need to see security as a form of insurance, i.e., the costs associated with having a security function are indeed than the alternative, which is not having them. Now, in some organizations, that gets dealt with legislatively, i.e., the government say you will have such a function and this is how you're going to deal with it. In other organizations, it simply becomes a case of, putting together a business case that demonstrates, well, these are your likely costs if you don't do this, and these are the costs if you do. Right.
I think that's
Sorry.
pretty much it for the moment.
Yeah. I was just having a quick look. Let's move on. Oops, sorry. Okay, let's talk about SIEMs. So a SIEM is a security information and event management system. And there's a nice little, very simple 4-step flowchart there on that page as well, straight out of Palo Alto Network's page on the SIEM process. And essentially a SIEM, you can think of it as in simple terms, as a log aggregator and log collector. So essentially, they collect data from a bunch of different places: firewalls, routers, switches, servers, authentication devices. I mean, even individual laptops and desktops in some environments. They pull all that data together, normalize it. That is to say, make it self-consistent, consistent with everything else that's stored in there. Perform both manual and automatic analysis to try and understand what's going on. See where you've got potential problems, understanding that, for example, when a whole bunch of devices behind a given router all say they've got a problem, it may actually be, for example, the router that actually has the problem. So that sort of event correlation takes place here as well. And then obviously that feeds into pinpointing security breaches, understanding how we're going to investigate and address as well. And that's very much a pipeline type process. So, data's always coming in at step one, and over those 4 steps, hopefully less and less of it actually needs to get through to the end of that process. So in various forms, SIEMs have been around a very, very long time. You may be familiar with an organization and a piece of software called Splunk. it's fair to say that Splunk is a very well-known SIEM tool, but certainly not the only one. And essentially, though, as I said, the more data they get, the better. It's best if everything in an environment gets sent to the SIEM, even if it gets aggregated by other devices along the way. And not only do they provide some analysis tools, they also provide a certain amount of reporting. Generally, there's some sort of dashboard function in them where they'll show what's going on in real time. It's always good in a SOC or a network operations team, for that matter, to have a nice big projector screen on the wall that has that dashboard showing, so that when people walk in, they can see what the SOC is up to. And generally, while this is also a SOAR function, there's some level of automation in here too. So typically you do want to try and automate some of the more common and mundane incidents away. So, things like, say, a network interface, becoming unavailable temporarily, that becomes an incident, of course, but it's probably, assuming that it, self-resolves, probably the sort of thing that you're happy to just automate away. And this is also where data goes to be stored for the long term. In many cases, governments require a certain amount of data retention for a certain amount of time. Internet service providers in Australia, for example, must store certain types of data for at least 7 years. And that's not an uncommon figure in finance as well. And therefore, a SIEM typically needs to be able to store that data in some form for a very long time. And obviously, in a large environment, that data store can end up being potentially the very largest data store the organization owns, which in itself becomes a problem that needs to be managed by the SOC. Okay, moving on to security orchestration, automation, and response, which is a SOAR. So a SOAR essentially builds on a SIEM, and we'll talk about this in a little bit more detail, but essentially takes a bunch of alert sources, including from a SIEM itself, and uses that information plus a bunch of other information to provide a single pane of glass view of security and provide a single response approach as well. So essentially, a SOAR is all about the automation. So the A in the SOAR is one of the key components here. So really, the key aim with a SIEM is to automate as much of the response process as is sensibly possible, and optimally to minimize the number of alerts or incidents that the SOC must actually respond to on a daily basis, as opposed to those that can either be dealt with in an automated way or can be triaged and identified as unimportant as quickly as possible. SOARs also aim, ironically, by being a tool that, in their own right, to address a problem that's been around for as long as security has been something that people have worried about in networks, and that is to try and get back to a single pane of glass type view. So instead of having Splunk to do certain things, authentication tools to provide, uh, various forms of authentication and authorization, having other tools that might, give you threat intelligence from third parties and so on. The whole point of a SOAR is to provide that single pane of glass, that single approach for the whole lot. Ironically, I say, because of course it becomes a tool itself, and obviously creating all of those tools requires a certain amount of automation and management, and that is, in my experience, an area where many organizations, don't manage to completely live the dream, as it were, because that in itself becomes an area of work and effort that somebody has to do. Some organizations do it better than others. As I said, a good SOAR will also automate a lot of the repetitive tasks and the lower risk alerts. and will address the full incident life cycle that I showed on a previous slide. They tend to therefore be built around the concept of playbooks, where there'll be very scripted processes that are used to define how a particular incident will be dealt with. And any that don't fit that mold are then, of course, floated up to somebody to deal with manually. But that then should become a lesson learned that gets used to improve the playbook the next time around. Overall, done right, it can reduce the amount of time that a SOC needs to respond to a major incident, potentially from days down to hours or even minutes. And overall, the takeaway that you should take from this is that it combines um, all of these different tools, seams, and everything else that goes with it, along with an incident management framework and a whole bunch of automation. Very quickly. Philip's asking a good question. What is the best approach to establishing correlation rules for a seam solution? That's a really good question, Philip, and it's actually a really hard question for organizations to answer. The best approach generally involves having a seam or a saw in what I'm going to call a learning mode. Years ago, Hewlett Packard had a tool called OpenView Network Node Manager, which had an event correlation engine built into it that takes the same approach that a modern SIEM also can, where essentially when you're first integrating or building it, you put it in a learning mode and you essentially use that to help define the correlation rules moving forward. Now that's not perfect because obviously novel correlations can occur at various times, but Pareto's principle applies to a great degree here. You can probably get 80% of the 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 problem correlations, as it were, and sort of 20 to 25% of the effort.
Okay, would we say that SIEM is an intrusion detection service and SOAR is intrusion prevention service?
It's a good question, but not really, no. SIEMs are very much your log aggregators, your log managers, and SOARs are your incident response and automation tools. Both will take data from both an IDS and an IPS, but neither really replaces an IDS or an IPS.
Okay, could you provide the name of a few source softwares?
Um, Honestly, I'd prefer not to, for the simple fact that I'm going to miss some important ones. But suffice to say that obviously we're talking about this in the context of Palo Alto material. There is a Palo Alto tool called XSOAR, XSOAR, which provides these functions that we're talking about here. But certainly many security vendors have equivalent tools, and it's certainly not for me in this course to discuss which ones are better or worse.
Okay, I think that's the questions on SIEMs and SOARs.
Mm-hmm. Okay, so we'll get on to incident analysis. How do you deal with an incident? What do you do? Something happens. And I'm going to use one of my favorite phrases here. You've already heard me use it every week these last 4 weeks. It depends, because every incident is by definition different. If they're not, then that in itself is a problem. If you're dealing with the same problem every day, then something's wrong. But the fact that every incident is different means that every investigation is different. That in turn means that working in a SOC can be some of the most frustrating work that you can do, but also some of the most interesting, because no 2 days should be the same. So you're typically going to collect data in a SOC from multiple different sources. For example, from enhanced detection and response tools, or antivirus tools, from network detection and response tools, yes, including firewalls, IDSs, IPSs, potentially from various forms of network traffic capture. You might have optical taps in your network where you sniff traffic all the time. You might have span ports which do the same thing electronically. You might have incident capture tools where, as an incident is occurring, traffic is caught and used for further investigation. Almost certainly event logs. We've kind of touched on that fairly heavily with our discussions around seams. And comment come through in the Q&A about the use of seams and source to store data long term. I will say that comment was 100% correct. I was simplifying the discussion because of the sheer cost and volume of data. Typically data that isn't needed for immediate response would be shipped off to some other storage. Might even go to something like an S3 Glacier bucket or something, depending on the business and its posture. Firewalls, IDS, IPS obviously are an important source of data. Threat intelligence platforms. Now, these can either be devices within your own environment that are looking at threats. They can also be third-party provided platforms that will tell you what's going on in the rest of the world. And that then leads also into malware sandboxes or honeypots, where either malware is run up deliberately in some sort of dynamic or static analysis platform. In Palo Alto's case, that would be wildfire or advanced wildfire type platforms, and its behavior is investigated there. And many security teams from either the large vendors or indeed from the various certs around the world also run live honeypots where they aim to capture malware that's out there and then do both static and dynamic analysis on it in a relatively safe environment so they can really understand how it operates and what to look for in the future. So all of this data gets used, all of this becomes input to various types of incident, and then of course is used to define and drive how you might choose to respond to that incident in time. This all feeds into, we discussed this a little bit in the previous slide, threat intelligence platforms. Many different organizations provide these. Many of the big security players have their own threat intelligence platforms. And essentially these organizations, which tend to be made up of a lot of different researchers and electronic sources as well, will look at what's going on. They'll be looking at the dark web, if you will. They'll be looking at what's going on the internet. They typically have devices embedded all over the world. Various customers willingly allow these platforms to be installed in particular hotspots. And these organizations and platforms basically give you good information on what is going on, where it's going on, what are the trends. They also tend to provide recommendations and playbooks on how you might both investigate and respond to common threats. So when, for example, a new major security vulnerability is announced, they will typically both tell you what to look for in terms of the investigation side, but also give you some suggestions and hints on how you might choose to respond both proactively, i.e. before the vulnerability becomes a threat, and reactively when you're actually dealing with the problem that's already occurred. And obviously, one of the big advantages of using these platforms is data sharing. You gain out of everyone else's experiences and learnings, but everyone else gains out of your experiences and learnings as well. So a good SOC will tend to interact with a threat intelligence platform in a bidirectional manner. And then malware sandboxes, touched on this a little bit 2 slides ago. Essentially, though, they tend to be automated these days, although it's not totally uncommon for a cert to manually run a sandbox and try and understand how a particular piece of malware works. So advanced wildfire in the Palo Alto case, as I said, is a good example of an automated malware detection tool that's designed to detect and help manage malware that may never have been seen in the wild before. SOCs and certs will use these, and the simplest form of a malware sandbox is a well-built, snapshotted virtual machine that can be reused and regenerated after each use. Because obviously, once you've installed malware on it, you almost certainly want to reset it back to some known good state after you're done. Essentially, though, they're designed to look to the malware like a real computer as much as possible. They'll run up the application, they'll look at what it does, what it tries to talk to, how it tries to talk to it, try and identify any other signatures of it, because that information is then used to define how firewalls might respond to seeing it in the future. And these sandboxes come in, obviously, as I alluded to, virtual machine flavors, where the simplest form is just a virtual machine that is snapshotted at a safe point in time and then used repeatedly to investigate malware or suspected malware. And there is also bare metal versions, because some malware will detect when it's running in a virtual machine, and will therefore not exhibit the same behavior that it might on a real laptop or desktop machine. Analysis and management tools. We've obviously covered two of them tonight, SIEMs and SOARs. But there's also network detection and response tools, which are very much designed to, as the name suggests, detect incidents and problems that are occurring on the network. The simplest, of course, would arguably be an intrusion detection system, through to endpoint and endpoint detection and response, or extended detection and response tools, which are essentially, in many ways, an advanced antivirus platform. And then, of course, your traditional antivirus platforms as well. There's also the concept of user and entity behavior analysis, where we look at how a user in a given environment should behave under normal circumstances, and then use that as a pattern or rule-based engine to determine when someone's no longer behaving the way we know they typically do. So, for example, if a particular user typically has a particular pattern of behavior, and then all of a sudden they're sending a whole bunch of data to third-party servers in overseas markets, that's probably, regardless of any other information that you might have, such as information from an EDR or an XDR, that's probably something that's worth further investigation. Before we move on, so Nima asks, so does SIEM cover SOAR? Pretty much the opposite way around, Nima. So typically a SOAR will use a SIEM as a part of its input.
Most of the other questions, I think, are all about DevOps and other things. We can go back to those later on.
Yeah, we'll roll back to those, no problems. Right, and in fact, we'll probably answer a few of them through talking about security operations engineering. So let's talk about security operations engineering. Really, it comes down to a couple of questions that particularly a larger organization is going to need to answer. In smaller organizations, these answers might be self-evident, because the SOC might be one person who has that role among 6 or 7 others, particularly in a very small organization. But that said, in a bigger organization with, say, millions of dollars of turnover, it's probably worth thinking about this in more detail. So first and foremost, the SOC needs to be supported. They're just like any other part of the organization. They have a certain number of users. They've got a certain amount of it tends to be something that needs a certain amount of upkeep and management. The SOC themselves are probably going to be focused on dealing with incidents all day. They're not going to have time to manage things like sandboxes. They're not going to have time to administer the systems that the SOC use. Now, maybe this forms part of a system administration function within the organization. That's not totally uncommon, of course, but quite often the security team want to keep things somewhat separate, because they can, as a part of their role, be dealing with things that are a lot more sensitive than the general operation systems that an organization might use. And of course, part of that too is who builds new tools. Now, a SOC can do that, of course, but again, a busy SOC probably won't have the time to do more than tread water, run the systems they've already got. If new tools are needed, or if, say, a new saw needs to be integrated with existing tools, or new tools need to be integrated with an existing saw, that potentially needs to be a security operations engineering role. So, and in a bigger organization, you can't really have a SOC without some form of security operations engineering as well. It is different to DevSecOps. In DevSecOps, the SOC support developers essentially, whereas security operations engineering support the SOC. So there's a bit of a key reminder here that is quite important with all of this. But before I get into that key reminder, I might just have a very quick look at the questions that are there.
So there's no new ones for the moment.
No new ones. Okay, that's all good. That's all right. So the key reminder, and I've harped on this a little bit tonight, security and the SOC team is there to enable the business. There's no good having a really, really secure business that as a result can't make money and therefore survive. And look, that means that from time to time, the security team are going to have to swallow a fairly bitter pill. They're going to have to agree to things that just don't make them feel comfortable. And it may be that it's just because there is no good business reason for them to disagree, and the business, besides that, is willing to accept that risk that a good SOC has actually told them about. Obviously, security is always a trade-off. It can be a trade-off between utility and risk. It can be a trade-off between usability and risk. It can be a trade-off between features and risk. And in every case, we're talking about risk as the other side of that coin. It is possible in some small cases to have both, but generally at some point, there's going to be a trade-off there. And obviously, too little utility, more broadly speaking, is a bad thing. That's where businesses go bankrupt. And if the business can't function, then that's not great for anyone, including the SOC. But at the same time, the SOC exists for a reason, and that is to stop the business making, poor decisions from a, security risk management point of view. And there is no right answer here because it does depend on the organization. The risk profile of a large bank or a government entity is going to very potentially be different to the risk profile of a .com startup who's moving fast and breaking things. And similarly, the risk profile of a mid-tier organization is going to be different again. All of these organizations will have their own view of how much risk management they're willing to wear and how much utility they're willing to forego as a result. So Georgia asks, and this is actually a really good question that goes back to the question about sandboxes. Georgia asks, do sandboxes ever have IP addresses if they're in a virtual machine? And could malware expose the sandbox? Yes, it can, and indeed, generally speaking, malware that, say, uses command and control, a command and control server somewhere, that malware by definition will need to be allowed to communicate with that control server to really understand how it's working and functioning. And in turn, that can expose the fact of the sandbox. A well-built sandbox won't look enough like a sandbox to really give that away, but of course, that's always a risk. In turn, what many of the larger organizations do is they'll have a pool of IP addresses that they use for their sandboxes, and they don't tend to reuse them in a hurry, as it were.
Okay. Are we on to more questions?
Yeah, I think so. We've got a couple more slides to go, but we've got a bit of time, so let's see
A few
what
more DevOps things, shall we?
Yeah, let's do that.
Is there much? What's the difference between DevOps, SecOps, and DevSecOps?
So DevOps very much is around development as being the key locus. That is to speed up the rate at which new functions and new features and functionality, and code more generally gets put into production, into operations, in other words. SecOps is about integrating the security team with the operations team. So essentially treating security as a part of the overall operational profile, and rather than doing it on a device or system by system basis, doing it holistically. And DevSecOps is really a combination of the two. So essentially treating development, security, and operations as a single focal, with security providing support to both of the other two focals in order to ensure that we have something that's operational, something that's as feature rich as the developers can churn out, and something that is secure.
How do we ensure, this is a bit like the last one. How do we, the other one before, how do we ensure alignment between the dev team and the management when we're transitioning to DevOps culture?
So that's a DevOps question if ever I've heard one. It's a really good one at that, I will say. Um, Days, most modern development teams are very comfortable with DevOps. It's been around long enough in various forms, be it agile or similar, that many developers, many graduate developers, and even many senior to experienced developers, right through to principal, are very comfortable with DevOps and generally like that more agile and flexible approach. Um, Management can be somewhat difficult to convince in some organizations, simply because it can appear like there's a little bit less rigor around DevOps. Management can't turn around and say, well, when will this specific feature be integrated and developed? And because of the way DevOps works in terms of storyboarding and feature development, there can be a little bit of rubberiness around those sorts of things. But that said, management can generally be convinced of its virtues just in terms of improving feature velocity and function velocity as much as anything.
There's a fun term, feature velocity.
Yes, yes.
Um, does DevOps involve any coding, as in programming languages?
Absolutely yes. Absolutely yes. Um, Generally speaking, the language, well, there is no one choice, dare I say, but you certainly find that languages like Python are very commonly used across NetOps, DevOps, SecOps these days. Partly because they are relatively modern languages that are relatively easy to understand, and while they are scripting languages, they're also compilable. There's a lot of flexibility in them, and certainly in the network heavy space and security heavy space, Python sees a real resurgence there.
One more DevOps question, then let's move on with the rest of the slides. In the world of parallel computing, is there not a way for DevOps and security to be integrated concurrently during development?
Well, that's the whole point of DevSecOps is, and it's not really about parallel computing as such. It's about process and procedure. The whole point of DevSecOps is to have security be a part of the overall process rather than something that sort of becomes a bit of an afterthought in many organizations. So rather than trying to make something secure after you've finished building it, you start with security as a key part of the process, and the operations team being a key part of the enablement of that process, rather than their traditional role of saying after the fact, you can't possibly do that, it's not secure.
Right. Let's keep on going.
Yep, cool. So next generation security. So this is pretty much the last slide of the night, actually, other than the regular Q&A type slide. So if you've got any questions, now's the time to throw them in the Q&A panel. But essentially, I mean, this whole course has been around next generation security, focused, of course, on firewalls. So the takeaway that I really want people to take from everything that we've covered is what next generation security means. Obviously, there's a certain amount of marketing ease in the phrase next generation security, but it's not a bad phrase to use to describe the concepts and the methods that we've been talking about for the last 4 weeks. So overall, modern security gaps, modern security tools are designed to close many of the more painful gaps that have existed in information system security since day dot. So obviously user identification, we talked about user ID in week 1. The whole point of that is, rather than having very broad permit and deny statements, because of one person might need access to something, you can actually go to the point of saying, well, if that user needs that thing, we give them that thing. Now, you might do that on a group by group basis, as we discussed, but the bottom line is that you can ensure that the right people have access to the right things at the right time with that. And application identification, obviously, same concept. We want to look at that from the point of view of allowing specific applications, and even in some cases allowing specific parts of specific web applications. So, for example, allowing Facebook chat as opposed to allowing Facebook, or vice versa. Content identification, obviously, no company wants its secrets stolen, but every company needs some form of internet access. So how do we identify our data? What does our data look like? And how do we make sure that that data stays where it should stay? And then, of course, security incident management absolutely has to be a part of this, which is that we respond quicker and far more precisely when there is an issue. And there will be a when for most large organizations. There's probably many whens per day. And many of those will be relatively minor, but every so often there'll be one that's a little bit more exciting than we want. And you want to know that you can respond well, precisely, and hopefully with as little stress and mess as possible. So with that, we'll get into any last questions.
Okay, there's always more. But wait, and please, everybody, put them in. We may even finish early tonight. Well, relatively early.
Relatively early.
We do say it's a 1 hour session, but we never go less than an hour and a half.
Yes.
How do we
Yes.
prevent data stored in the cloud from hacking? That's a very wide question.
That is a very wide question, but I'm still going to give it a go at answering it. So there's a whole concept of what's called data loss prevention, or DLP. There's many different tools that you can use for data loss prevention, but the long and the short of it is, it's a combination of managing security and permissions in the cloud, which is absolutely a topic in its own right. In fact, it's a topic that I teach for IT masters as part of cloud architecture, as well as potentially using various technologies, including data loss prevention, to identify data that is leaving for places that it shouldn't, and preventing that from occurring in real.
Are you still there?
I'm still here. Can you hear me? Yeah, yeah.
It just felt like you dropped out.
Oh, yeah, no.
Next question. What approaches can we take to gain support from leadership and developers for adopting a cloud native architecture?
So I'm going to use my favorite 2 words again. It depends. So generally, leadership are most interested in cost benefit analyses, of course. So in order to go cloud native, they need to see that it's financially and economically and procedurally worth it. And obviously, dollars are absolutely part of that, but regulatory and legislative environment may well be as well. So some organizations simply cannot move into the cloud, no matter how much it might make sense technically, simply because of, say, legislative requirements that data be exactly where they know it to be. Generally, it's management that are, particularly in the Australian context, are the hardest to convince in that sense. Developers are generally pretty open to it, particularly with a with a serverless or zero touch type architecture of that nature. It's the thing, dare I say, tongue in cheek, and therefore developers are generally fairly keen to look at that. And yes, that's a broad brush, but I think it's a fair one. Whereas, if it's right to do, it's a case of building a business case for it. And again, that's really something that as I say, I spend 12 to 14 weeks working with students as part of IT Masters itself to do.
Just before I go on to questions, I'll answer a few of the little bits and pieces that are coming up in the chat as regards exams and everything. So the final exam will be posted late tomorrow. So have a look at it tomorrow evening, Australia time, or on the weekend, or early next week. And also, in order to get to the exam, you need to pass the quizzes for every week. And then once you've passed those quizzes, that opens the exam on this platform. If you're having trouble finding the exam, they are on the learn.itmasters.edu.au learning platform, where all of the things like the slides from every week, the Q&A, all sorts of information. As a result of a couple of requests last week, we've been posting the Q&A there as much as we possibly can. So I would encourage everybody to do that. And I would also say that in the future, there may be added benefits for getting the certificates, although I will remind everybody that if you do 3 of our approved short courses, and nearly all of them are approved, that can get you a credit into one of our paid courses as you go down the path on that. So it is a very good value for money, because as you heard, Ian is one of our mentors that teaches subjects that overlap with these and teaches them in very much the same way. So what you get here is what you get in the postgraduate degrees. Just a couple more questions. I saw that you answered what's next in NextG security, so that's interesting. And I will talk about some upcoming courses for next year in a minute. Have you had any frustrations with the intersection of incident response and security incident response in reference to definitions, processes, and org structures between the two? Basically, what is just an incident dealt with by the IT team, and what's a security incident dealt with by the security incident team, and who deals with what?
That's a really good question, Brian. Essentially, look, there's always going to be some areas of demarcation when it comes to these matters, because there is a lot of overlap between what is a security incident and what is an IT incident. Because, among other things, at its root, availability concerns become a security concern. Um, Generally speaking, this is and this is sort of where things like the IT infrastructure library do sort of start to come into their own a little bit, because you can start to use it to in combination with processes and playbooks to determine how and when something gets escalated from the IT team to the incident response or security operations team. And it generally is that form of escalation too. Obviously, the security team are going to be first and foremost focused day to day on, security alerts as seen by their, SIEM and or SOAR platforms. But occasionally, one of the inputs is going to be the IT team saying, "Hey, we had this server go offline and now it's behaving really oddly. Can you take a look?" Just to take an example. Can that be a frustrating process? Yes. Can it be a highly political process, particularly in a large organization? Also, absolutely yes. And generally, this is an area that in terms of team building, storming, norming, forming kind of approaches, is going to take some time to thrash out if a SOC is being stood up from scratch.
Hey, in DevSecOps, how do you prioritize security tasks in a CI/CD pipeline without slowing down the overall development and deployment process?
So really, the question as asked, which certainly not a bad question at all, but as asked, it's sort of asking almost the wrong question, and that's not to diminish the question at all, though. Just to be very clear, um, if you're doing DevSecOps correctly, there won't be any need to prioritize security tasks, because security becomes a part of the CI/CD pipeline. So essentially, similar to the way DevOps will have a test-driven development approach, that is, tests have to be built in order for code to pass the tests, in order for code to be put into production. That's the way test-driven development essentially works. So with DevSecOps, essentially all you're doing is adding security into that same pipeline in the same way. Now, yes, developers, when DevOps first became a thing, complained that this test-driven development was slowing them down because they had to think about their tests first. But in practical terms, they've long since figured out, well, most of them have anyway, that actually it speeds them up, because it reduces the amount of time they're going to fixing bugs after the fact, in production. Essentially, DevSecOps takes that same mentality. Yes, there's a small amount of overhead in, building that, security framework, that testing framework up front and making it security focused. Yes, it means that developers probably need to spend a little bit more time up front, writing type safe code and all of those other things that they'll need to think about. But that does pay for itself in the long term and then even in the short term. The numbers really haven't changed in well over 25 years. But essentially, for every phase of software development, the cost of fixing a bug, whether it's a software bug or a security bug, goes up about an order of magnitude. So if it costs you $1 to fix when you're, doing the design specification, it might, by the time you're getting into production, cost you, $10,000 or $100,000 to fix. So obviously, the quicker and earlier you stop problems happening, the cheaper it is, and obviously that then means that developers are ultimately happier because they're spending more time cutting code as opposed to fixing bugs.
Hey, how can next generation technologies like AI, ML, and automation enhance incident management processes, especially in complex hybrid environments, to minimize response time and improve incident prioritization without sacrificing human oversight?
That is a really, really, really good question. I love it. Um, so obviously, if we talk about a SOAR for a moment, our automation response platforms, um, artificial intelligence is and probably more broadly machine or more specifically machine learning is absolutely a valuable component of that because that's a part of how you automate responses to common threats, because even a common threat isn't necessarily going to look identical each time, and therefore your traditional pattern-based scripting to address it isn't necessarily going to work that well. But it's the sort of thing where machine learning can absolutely work very well. So obviously, though, nothing beats a human in the loop for certain types of response and management, particularly more complicated ones. But the aim here is to ultimately deal with the 80% of alerts that really only require 20% of the brain power, and therefore, are the sort of thing that can get it away fairly quickly using machine learning as possible. And again, the whole thing here is the more of those that you can deal with in double quick time using a computer to do the thinking, the more that those people that are sitting in the operations team can actually focus on the alerts that really matter, which are the complicated, challenging ones that really require some brain power to solve.
And it's true that thus far there has been a number of studies which have shown that people who are given testing where they've done things without AI help, they've done things with AI help where they're encouraged to trust the AI, and then they've done things with AI help where they're encouraged to distrust and question the AI. The
Hmm.
results always turn out that the people who do things where they are encouraged to distrust and question the AI get overall much better results than any of the other groups.
Yeah, and look, I mean, working in a security operations team, you've got to be skeptical. That's a part of the job. You've got to treat everything with suspicion. And yes, that does include the security tools in which they use and operate. Um, but that said, like any tool, yes, they have their limitations. Yes, they have their constraints and shortcomings and blind spots. But at the same time, used correctly and judiciously, and not just treated as a silver bullet, they can absolutely help address some of the more complicated and drudgery work type challenges that we all face. And when I say complicated, I mean complicated to script. Obviously, a good SOC or a good automations team is going to script away anything that can be, anything that can be matched on pattern. But pattern matching is in no way perfect. And sometimes a little bit of machine learning goes a long way in that regard.
We might finish up on this question. There's a couple here, but I think
Mm.
most of them have been covered and could potentially also turn up in the forums. But this is an interesting one from Andreas. According to CNN, Mike Lynch, who, forgive me if I'm wrong, but he was the guy that died in his yacht recently.
Yes, yes, he was.
He did not trust cloud services and always kept data drives in a secure compartment of the yacht wherever he sailed. Is this a viable security model? One would think not if the yacht sinks. Can you speculate on the operational effectiveness of this approach, please?
Yeah, it depends on the threat model that you're dealing with. Um, the obviously the threat most of us wouldn't have us being on $100 million yacht to start with, but certainly also probably didn't um, you know none of the data that we're storing is going to be of sufficient interest to a third party to make appropriately secured cloud inappropriate, as it were. Um, the Certainly, if you look at some organizations, and I deal with several large organizations on a daily basis who have very stringent anti-cloud policies. And in some cases, that's because of legislative requirement. In other cases, that's because of, a risk profile that basically says, we don't trust these things yet. And in a couple of cases, it is just, dare I say it, sheer bloody mindedness. Um, but nonetheless, in those cases, they're doing something very similar, which is, storing data, in data centers that they potentially own, or at least have, fairly stringent management access to. And obviously, that then raises a whole bunch of additional threats and risks that you've got to deal with. And obviously, Mike Lynch's storage of the data on a vessel that is now at the bottom of the Aegean Sea, I believe, probably highlights one of the threats that data, which is it becoming, fairly, dare I say it, permanently unavailable. Years ago, I used to work for a marine research institution, and we used to have laptops fall off the back of boats all the time. And not once did we ever manage to, even using forensic data recovery techniques, manage to actually retrieve data from those laptops, because salt water, as it turns out, is really, really bad for electronics. Um, so obviously, assuming that your threat profile is such that you don't trust clouds, then does your threat profile also mean that you do want, redundant, cold backups in other locations as well?
Isn't that the whole thing with the old tape backups? They used to have to be taken
Yeah,
off site in multiple places.
look, absolutely, and with good reason. And the other thing that many using tape forgot and still do forget is that tapes themselves have a service life. They do go moldy. The substrate that tapes are made of is actually very, very attractive to common household molds, and therefore rotating the tapes, i.e., not just putting it in storage for 7 years, but routinely retrieving them, reading the data off them, and writing them to new tapes is actually a part of the process if you're required to store that data for the long term.
Or even
And
what worse is when people record over the same tape all the time and it
yeah,
wears out.
yeah, I mean, and I mean, years ago, I worked for an institution that had a major data center fire, and unfortunately, the backup process had kind of, well, failed, to the point where the most recent set of tapes, which had been used for the last several nights worth of nightlies, were actually sitting in a cardboard box on top of an uninterruptible power supply that caught fire. So fairly prominent threat profile there. Basically, multiple petabytes of data literally went up in smoke as a result of that.
Wow.
So these are the sorts of risks and threats that, yes, a SOC will need to deal with. So they're not all purely electronic and, hackers and script kiddies at the other end of a, ADSL line.
Exactly. And I think at that note, we should probably call it a night. I've got a few things to just chat about before we all go tonight. First thing is to say really big thanks to everybody for coming along. For 4 weeks in a row, we've had really great attendance. And of course, the videos, the transcripts, everything will be available on our site. So we encourage you to look at that, and we make them available for an extended period of time as well. We have courses that have actually been up there for 8 or 10 years while we get around to replacing them with updated information. This is our last new short course for this year, so I'd encourage you to look back through the catalogue. There's close to 50. In fact, there may even be 50 now on our website at itmasters.edu.au, and just see if there's anything else out there that takes your fancy if you haven't done any before. For next year, we have a similarly big year planned. We have about 6 brand new short courses up and coming, which will cover such topics as a refresh on pen testing. There will be an AI short course. There will be possibly one on TOGAF. We're still deciding about that. There will be an update to CCNA, which is one of the most popular courses that we've done various versions of over the years. And there'll be something on project management. I think that covers the 6. If it doesn't, there's one I've missed, but we'll get around to that. We're in the midst of the planning stage already for that, because we would like next year to be a big year for courses. We also intend to do a few extra little tidbits along the way where myself and the mentors might have a little conversation each week before and after the short courses, and just post that on media so you can see a little bit about what might be coming up or what was in last week's one if you happen to miss it along the way. But as I said, thank you again for coming along. A big thank you to Lil for riding shotgun on the chat every week and posting all those messages. It's really helpful to do that. And of course to Ian, without which none of this would be possible whatsoever. And we're really, really grateful to you for coming out tonight.
Thank you very much for your time. Appreciate it.
On that note, have a great night, everybody, and we'll see you in 2025. Thanks.
See you later.